So example 7.2.2. So another hypothesis test for one proportion using one prop z-test. Okay, so some of you, after looking at or listening to the last example, maybe that made complete sense. So maybe you might want to try to just pause the video and see if you can work through this example on your own and then play back through the video to make sure that you are correct. So a researcher who's studying the effects of income levels on breastfeeding of infants hypothesizes that countries where the income level is lower have a higher rate of infant breastfeeding than higher income countries. It's known that in Germany, considered a high-income country by the World Bank, that 22% of all babies are breastfed. In Tajikistan, considered a low-income country by the World Bank, researchers found that in a random sample of 500, there's our little n, new mothers, that 125 were breastfeeding their infant. Okay, so this is a count in a category, so that's our value of x for qualitative data. At the 5% level of significance, so there's our value of alpha, does this show that more than 22% of all new mothers in Tajikistan breastfeed? So again, we're going to follow through the same steps in phantoms. So again, the P stands for parameter, or population parameter, if we want to think about it that way. And so in this case, we're going to be looking at the proportion of all new mothers in Tajikistan who breastfeed, which means the corresponding random variable that we're going to be getting information from the sample is going to be the proportion in just our sample, which was 500. So the proportion of 500 randomly selected new mothers in Tajikistan who breastfeed. Okay, the next letter or next step is the hypotheses, H for hypotheses. So we're going to set up the null and alternative hypotheses. Qualitative data, our parameter is P, and we want to test that more than 22% of all the new mothers. So again, this is going to be a greater than and 22%. So 22 divided by 100, we get 0.22, and that makes our null hypothesis P equals 0.22. And our level of significance they gave us, alpha, was 0.05. Okay. Our next letter in phantoms is A, which stands for assumptions. So again, all of these hypothesis tests have a list of assumptions that need to be checked, and those assumptions are on your cheat sheet, so you do not need to memorize those. Again, one of the checks for all of our hypothesis tests is to check that a simple random sample was taken, and as we look up in the paragraph, they did give us that information. So a simple random sample of 500 new mothers was taken. Okay, that was stated in the problem. Part B says to check that there are only two categories for each individual object, so that we're dealing with a binomial experiment. So in this case, again, our object here was a new mother, so either a new mother breastfeeds or she doesn't. So we've just got these two categories for qualitative data. So again, it'd be nice if we could use the normal distribution and not the binomial distribution. So we're going to check the conditions to see if that is allowed. So we've got some conditions to check. So first we're going to take n times p and make sure that that is at least 10. So n was 500 and p was 0.22. And so if we multiply those, we get 110, which is definitely at least 10, so that condition checks out. N times 1 minus p, so we're going to get 500 times the quantity 1 minus 0.22. And so if we compute that, we get 390, and that is also at least 10. Again, no cap n was given in the problem, so we're just going to assume cap n is greater than or equal to 20 times little n, and so we're going to check that condition as met. So the conditions are met, so the sampling distribution of p hat can be approximated with a normal curve. So we're going to use a test that uses the normal distribution to compute the probability. So as we name the test used, so our next letter in phantom is n, so the conditions that we checked here were for the one proportion z-test. And Our next letter in phantoms is T, so for test statistic. So again, we're going to think about the sample statistic and then the standardized test statistic that we get from that. Okay, so as we input things on the calculator to get these values, we're going to go to one proportion z-test. So you'll push stat and arrow over to test and find one proportion z-test. Next to P0, we're going to type in 0.22. X out of n, we've got 125 out of 500. Again, next to proportion, this is where we highlight whether we have a left-tailed, right-tailed, or two-tailed test. And so next to HA, we had greater than P0, so we need to highlight the greater than. And then we'll highlight calculate and hit enter. Okay, so once you press calculate and hit enter, the output screen we get is here. Again, before we look at any of the other values, we need to check that that top part of that screen matches what we have set up in our alternative hypothesis, which it does. Proportion is greater than 0.22. And so on this screen we have these values that we need. So our sample statistic is the sample proportion, so that is p hat, and that is on the output screen as 0.25. And then the standardized test statistic, so the z-score, we would get about, so again, if we would actually compute the p hat minus p0 over the square root p0, 1 minus p0 over n, we would get 0.25 minus 0.22 in the numerator. And in the denominator, we would get the square root of the quantity 0.22 times 1 minus 0.22 all over 500, and the square root of that entire quantity. And so again, that z-score is on the output screen, and so we would round that to about 1.62. So there is our test statistic z-score. So again, z-scores are counting standard deviations away from the claimed value. So this means that the observed sample proportion that we saw in the data is about 1.62 standard deviations above, again, since it came out positive, the claimed population proportion in the null hypothesis. So the next letter in phantoms is O, so we're going to obtain the p-value and then draw a picture to make some meaning out of these numbers. So keep in mind that on that output screen, again, our p-value is here next to p, but it's not p, it's the p-value. So we're going to write p-value is about, if we round that off to 4 decimal places, we get 0.0527. And so now if we make a picture with all of these numbers, so again, our sampling distribution of p hat is a normal curve. It's centered at 0.22 because that was our hypothesized value. So again, whatever the claim is goes here in the center. Z-score for center is 0. In our data, the actual observed value of p hat that we saw was 0.25, and the corresponding z-score there was 1.62. And so the area to the right of that is our p-value, which came out to be 0.0527. And so now again, these p-values we compare to alpha, which in this case again was 0.05. And so our p-value is either less than or equal to 0.05 or greater than 0.05. In this case, it's greater than 0.05. Which means that this is not an unusually high value, so we're not going to reject HO, and we're going to say we do not have evidence of the alternative hypothesis. So in this case, since our p-value is greater than this value of alpha they gave us, 0.05, we fail to reject HO. Which means that there is not significant evidence to conclude HA, so that the proportion or percentage of all new mothers in Tajikistan who breastfeed is more than 22%. So again, the power of inferential statistics is that we are concluding for all, the entire population, based on evidence we saw in just a sample. And I should have filled in my last letters here for phantoms. So M was make a decision, and S here was to state a conclusion in the context of the problem.